So chapter number 1, real numbers. Okay, in that first topic is Euclid's division lemma. Okay, so what do you mean by lemma? First tell me that. What do you mean by lemma? You can turn on the mic and give the answers. What do you mean by lemma? Okay, Shravani is saying that it is an algorithm. Okay, proven statement used to prove another statement. Okay, any other answer? What do you mean by lemma? Yes, any other answer? Only both Shravani's gave the answer. Okay, prerna proven statement. Okay, fine. Yes, it is a proven statement क्योंकि लेमा का दूसरा नाम होता है algorithm. Algorithm यानी एक particular set of rules. Okay. So we will see now. A lemma is a proven statement which is used to prove other statements. यानी जैसे हम लोग law बोलते हैं simple language में. Okay. Ohm's law आपको साइंस में होगा. Like that, it is a proven statement and it is applicable to other statements also. तो वैसे ही लेमा भी एक proven statement होता है and it is applicable to other statements also. Okay. Next, Euclid's division lemma tells us about the divisibility of integers. Yes, what do you mean by divisibility of integers? You can turn on the mic also and give the answers. What do you mean by divisibility of integers? Am I audible to everyone? Am I audible to everyone? What do you mean by divisibility of integers then? This is my question. Okay. See the next point. And positive integer a can be divided by any other positive integer b in such a way that it leaves a remainder r which is smaller than b. We have also seen division algorithm in chapter number 2, polynomials. Yes, who will tell me what is that division algorithm? What is that division algorithm?
Dividend is equals to divisor into quotient plus remainder.
Correct. Dividend is equal to divisor into quotient plus remainder. This division algorithm in polynomials, this is only the Euclid's division lemma. Okay. Now, what is the use of this Euclid's division lemma? What is the use of this? Why we are studying this? Why it is given in our syllabus? To find HCF, correct. Euclid's division lemma or Euclid's division algorithm is mainly used to find HCF. What is HCF, by the way? What is HCF? Okay, its full form is highest common factor. What are factors? What are factors? What are factors? In your own language also you can give the answer, no problem. Hindi, Marathi, English, whatever language you are comfortable. Numbers which when divide, numbers by which given term is completely divisible. Okay. Okay. Numbers by which the given term is completely divisible, that are called as factors. Okay. Now see here, I'm writing one value here, 12 divided by 3. Now tell me, 3 is what of 12? 3 is the factor of 12. And 12 is what of 3? And 12 is what of 3? Just say 3 is the factor of 12. Yes, 12 is the multiple of 3. Okay, 12 is the multiple of 3. तो factor और multiple का difference आपको समझ में आ गया. What is factor and what is multiple? Okay. So now here what they have said, any positive integer a can be divided by any other positive integer b in such a way that it leaves a remainder r which is smaller than b. So suppose we will take any positive integer. Suppose we will take 112 divided by 7. I think so it is divisible. So we'll take 9. Okay, 112 divided by 9. So how we do this operation? We write 112 inside the division sign because it is the dividend. 9 is our divisor, so we write it here. Okay. Now we perform the division. So 9 ones is 9. What is remaining? 2 is remaining, and this 2 will shift down. 9 twos is 18. So what is the remainder? 4 is the remainder. So according to this Euclid's division lemma, how we will arrange this? 112 is nothing but 9 multiplied by 12 plus 4. Yes or no? Division algorithm में भी हम लोग ऐसे ही करते हैं while solving the polynomials. Yes, it is not completely divisible. We are applying Euclid's division lemma to it. Okay, now you can see what they have said in the statement here, any positive integer a. So here in this case, our positive integer a was 112, can be divided by any other positive integer b. So b is equal to 9 in such a way that it leaves a remainder r. So what is the value of r here? R is 4, and which is smaller than b. Now check whether this 4 is smaller than this 9, yes or no. Remainder always comes smaller than the divisor. Okay, so this is our Euclid's division lemma. भी इसको use कैसे करते हैं, we will see that also in the further slides. Is it clear to everyone? Till here, any doubt, any problem? Okay. Euclid's division lemma provides us a stepwise procedure to compute the HCF of two positive integers. Okay. Now we will see the theorem. Oh, we will see the statement of Euclid's division lemma. Now what they have given positive integers a and b, there exists unique integer q and r satisfying, okay, satisfying a is equal to bq plus r, and r should lie between 0 and b. It should be greater than or equal to 0 but less than b. Okay. This is the statement of Euclid's division lemma. Now we will see one example also on it, where A is what? In this expression, A is the dividend, B is the divisor, Q is the quotient, R is the remainder. Okay. Now, for example, if we want to divide 119 by 8, we get 14 as the quotient and 7 as the remainder. Now, suppose if we start dividing it, okay. So 119 divided by 8. So 8 ones are is 8 minus, here it will come 3, 9. 8 fours are is 32. What is the remainder? 7 is the remainder. You can see 14 we got as the quotient and 7 we got as the remainder. If we arrange it according to the Euclid's division lemma, so how it will come? Yes, how it will come? According to this, A is equal to BQ plus R. We have to arrange in this form. So what will be the answer? What will be the answer? How we will do the arrangement? How we will write it?
119 is equal to 8 into 14 plus 7.
Okay, 119 is equal to 8 into 14 plus 7. Now you can see here this value of R. It is between 0 and B. B is nothing but the divisor. You can see the value of R is greater than 0 and it is less than the divisor for this example. Okay. Now how to find the HCF using Euclid's division lemma? ये तो ठीक है, हमने division lemma apply करना सीख लिया. Now we will see how to find the HCF. Okay. Okay, use of Euclid's division lemma or algorithm to find HCF of two positive numbers. For example, we have to find the HCF of 125 and 35. By the way, is there any other method to find the HCF of numbers? Is there any other method? And if it is there, what is its name? Yes, prime factorization method. ओके, प्राइम फैक्टराइजेशन मेथड, जो कि काफी इजी मेथड है और हम सब लोगों ने उसको यूज किया है इन आवर लोअर क्लासेस. ओके, सो हियर we are not going to use prime factorization method, but now as your exam is in the form of MCQs, you can use that method also for getting the answer. वो थोड़ी ना देखने वाले कि आप कौन सा मेथड यूज कर रहे हो to get the HCF. You can use that method also. Okay. So now first we will solve this with the help of prime factorization method. Then we will apply Euclid's division lemma and get the answer in both the cases. Okay. For solving it with the help of prime factorization method, how we will do it? Yes, who will tell me? Yes, Viraj, the HCF is correct. Who will tell me how we are going to do this using prime factorization method? How we are going to do this using prime factorization method? Yes, HCF is correct. No doubt HCF is correct. How we are going to do this? This is my question.
First, we will write one number like 125 or 35.
Okay, 125, I will write it here. Okay, next.
Now we will choose a number which will divide both the numbers like 5.
Yes, it is correct. It is divisible by 5. But what is the criteria? We start from 2. Okay. यहाँ पे जो भी फैक्टर्स हमको मिलने वाले हैं, they should be the prime numbers. Okay. So first even prime number in the world is 2. Okay. So we start with 2. 2 से दोनों divisible नहीं है. Next we move to 3. 3 is also the prime number. So उससे भी divisible नहीं है. Next we move to 5. Okay. Carry on. 5, here it will come 25, and here it will come 7. Next, by what I will divide? Yes, Shravani.
Now we will divide 25 by 5 and write 7 as it is.
Correct. We will divide 25 by 5 and we will write 7 as it is. Next.
Again, we will write 5 and write 7 as it is.
5 ones are and 7 as it is. Okay. Next.
Now we will divide by 7.
7 ones are and here also 1 it will come. Okay. Now what is the HCF here?
5.
How?
Because by 5, both the multiples are divisible.
No. From these factors, we have to get the HCF, na? See here, now the factors are what? 5, 5, 5 and 7. So जो pair form हो रहा है, that is our HCF. Okay. The factors which are forming the pair, that is our HCF. This is how we get the HCF using prime factorization method. Now, our actual topic, Euclid's division lemma. So here 125 and 35, which one is bigger? 125 is bigger, so it will come inside the division sign, and 35 is smaller, so it will be the divisor. Okay, so 125 is our dividend and 35 is our divisor. So 35, how much za is less than 125? 35 2s is 70, 3s is how much? 35 3s are okay. 3s is 105. So what will come here? Here we will get 20. Okay. Now this 35 will become our new dividend. This 35 will become our new dividend. And this 20 will become our new divisor. Okay. So how we can write now 125? 125 is what? It is divisor is what? 35 multiplied by 3 plus 20. Using Euclid's division lemma, we can write it like this, na? Okay. Now our new dividend is 35 and our divisor is what? 20. Now 20 ones is 20. If we subtract it, what we will get? 15. Okay. So here it will come 1 and here it will come plus 15. Using Euclid's division lemma, I'm arranging the things. Okay. Next, this 15 will be my new divisor and this 20 will be my new dividend. Okay. This 20 will be my new dividend. So 15 ones is 15 minus 5 is remaining. Okay. Now, using Euclid's division lemma, we will write it 15 is what? It is 15 in, sorry, 20, not 15. 20 is what? It is 15 into 1 plus 5. Okay. Next, 15 will come here. It will become the new dividend. If we divide it, what we will get? 3 is 15. 0 is the remainder now. So now 15 will be what? 5 into 3 plus 0. तो जो आखिरी में जो डिवाइजर हमको मिला है आखिरी में जो हमको डिवाइजर मिला है, यू कैन सी इट हियर आल्सो, दैट इज आवर HCF. This method is also called as long division method. Is it clear to everyone? Using prime factorization method and using Euclid's division lemma, we can get the HCF. Is it clear to everyone? Okay. So I will write two numbers. You find out the HCF of that. Find HCF. Yes, it is also called as long division method. In lower classes, this method is used, long division method in 7th, 8th. So find the HCF of 75 and 525. Find out the HCF of 75 and 525. Okay, Viraj, that's correct. Okay. Okay, most of you got the answers. So you can do it orally also. अभी दोनों नंबर्स में जो कॉमन फैक्टर होगा, अगर सपोज ये नंबर को डिवाइड करता है कंप्लीटली, दैट मींस दिस इज द HCF. ओके. Shravani, you are telling 5 as the HCF. No, it is wrong. अगर नहीं जम रहा है तो आप डिवीजन परफॉर्म कीजिए. 525 डिवाइडेड बाय 75. So 75 2 is 150, 4 is 300, 5 is 375, 6 is how much? 450, and 7 is 525. So this is our HCF. Okay. Because in the first step only we are getting the remainder as 0. There is no need to further divide it. Okay, find the HCF of 79 and 83. Yes, Firaj, it's correct. Yes, what will be the HCF of 79 and 83? Okay, 1 is the HCF. Why 1 is the HCF here? Can you tell me the reason? Both are prime numbers, correct. And for prime numbers, there is no common factor except 1. So that's why the HCF for 79 and 83 is 1. So you should be able to find the HCF of any two numbers using Euclid's division lemma. Let's move forward to the next topic. Fundamental theorem of arithmetic. These theorems and their statements can be asked in exams. So you should know the statement. Every composite number can be expressed or factorized as a product of primes, and this factorization is unique except for the order in which the prime factor occur. Okay. This is nothing but we are finding the factors of any number, we'll see the example. Let us take an example of prime factorization of 140. Okay. So in lower classes, there are different methods, like tree method is also there for prime factorization, and column method is also there. Okay. So we can do it by both the ways. 140. Okay. Either side, ये जो अभी ये दो side है ना, we are having this left and right. So on the left side, we will get the factors. Okay. So if I will start with 2, if I divide by 2, I will get 70 here. Okay. Now we cannot split this 2. We have to split this 70 only. So here again, this 70 is divisible by 2. So I will divide by 2. So here it will come 35. Okay. Now we cannot split this 2. We have to split this 35 only. So here we will get, it is not divisible by 3. Next prime number is 5. So we will divide by 5. Here we will get 7. Okay. And at the last, 7 and 1. So these are nothing but the factors. 2, 2, 5, 7 are the factors of 140. प्राइम फैक्टराइजेशन से तो हम लोग और भी जल्दी और इजीली निकाल सकते हैं. 2 से डिवाइड करने के बाद यहाँ आ जाएगा 70. 2 से डिवाइड करने के बाद here it will come 35. Next 5 7 and 7 1. Okay. So how we can write 140 then? 140 can be written like this: 2 to the power 2 multiplied by 5 to the power 1 multiplied by 7 to the power 1. Okay. This theorem is quite easy. Is it clear to everyone? Okay. Now, what is the relationship between HCF and LCM of two numbers? Yes, what is the relationship? What is the relationship? Yes, anyone? What is the relationship between HCF and LCM of two numbers? Yes, Valla Katti. No one knows what is the relationship between HCF and LCM. ये सब कुछ lower classes में हुआ है आप लोगों को. Yes, Netal has given the answer. HCF multiplied by LCM is equal to A into B. Okay. So the relationship between LCM and HCF is that LCM of any two numbers multiplied by HCF of those two numbers, it is equal to product of numbers. Okay. So you should know this relation because they can give you the HCF, they can give you the two numbers and they will ask you to find the LCM. So using this relation, we can get it immediately. Okay. See, whatever this 3-4 slides we have covered up, you will have to write it in your CW. Okay. Next, we'll start the exercise then. First question, use Euclid's division algorithm to find the HCF of 135 and 225. Sorry, today there is no attendance link. Vallakatti, you take the screenshot and send it to me. Okay, find out the HCF of 135 and 225. So you can use long division method. 225 will come inside, 135 will come outside. Okay. So if we divide it, 1 is 135 minus, here it will come 0, 7 plus 1, 8. Okay. Now this will be my new divisor and 225, sorry, 135 will come here now. 135 will come here. 1 is 80. So 20 plus 30, 55 will come here now. Now 80 will come here. 1 is 55 minus 5 plus 20, so 25. Okay, now this 55 will come here. 2 is 50. Okay, so what is remaining? 5 is remaining. Next 25 will come here. 5 is 25. Remainder will be 0. So what is the HCF then? What is the HCF? 125 and 135 and 225, it should come 15 because both come in 15 stable. Please check where is the
minus 135 is 90.
it's 90. Okay, here there is a mistake. Okay, fine. Again, we will solve it then. 225. Here it will come 135. 1 is 135. And here comes 90. Okay. This 135 will come here. 1 is 90. So here it will come 45. This 90 will come here. Na? Yes, HCF is 45. Correct. So 2 is 90 minus here it will come 0. So the HCF is 45 in this case. Both come in 45 stable. Okay. HCF is 45. Similarly, solve this second and third one. Solve the second one, 196 and 38220. For last year students, this topic was not there. Okay. Euclid's division lemma unko nahi tha, but for your syllabus it's there. So in this question number 1, second and third, you will do it by yourself. Okay. Tomorrow we will continue with second question of this exercise. You can find out the answers now also. (196) is that CF. Okay. 38220. That means it is completely divisible by 196. Okay. For 867 and 255, also find that CF.